Set. Let's define two variables, x and a. They're variables. Whoops. I think it did over there. I got a function. What's the function? It's going to be, let's see, x cubed, I know this seems strange to you, minus 3. And the solution to that equation, at least a simple one, would be the cube root of 3. Pretty simple, right? So, that's using Wells's technique. And Wells's technique, what you have to do is get an approximation. And a good approximation to the cube root of 3 is approximately 1.4. I just want to remind you what we did in the first few problems. We would say, oh, our first guess 1.4 plus a. I'm sure you remember me doing this, dot expand. Right? I do that. Then what I take the last two terms. I'm just going to remind you what we've done before. And I solve that for its root. And then I take that old guess, which was 1.4, and add on the correction. And I get this number over here. And I want to claim I'm seeing that number right over here. All right? Then what do? You repeat it using this number now. I'm not going to finish this one out, though. There's a point to it. I don't think I'd use this technique to find the cube root of 3. We'll go through that in a moment, though. So what do? F of that number plus a. We expand. And then what I do, I take the last two terms. These are the linear part of it. And I solve for the root of that. Again, the reason, if a is a really tiny number, these first two terms are incredibly small then. It's the last two terms that have an impact on the problem. So what do you get over here? You're going to get, let's see, solve. I'm just going to do two steps, by the way. This for its root. And then I take the last guesstimate, and then I'm going to decrease it by this amount over here. Type that in. And then we get this next number. So we've done that before. There's no doubt about it. We've done many of those problems. Certainly I was sort of cheating using a digital computer. I was quite impressed by Wells's text, where they were actually doing computations. And even typesetting it must have been very difficult back then, where they had to take someone's chicken scratch and typeset it. Right? They were actually typesetters. Mathematics now, for the most part, is being typeset by the writers, not by some career typesetter. Now, granted, I guess if you get to the upper echelons of mathematics, there are career typesetters. I know some of the big publishers are from universities, and what they do is they use their students to do the typesetting. All right? The students do learn by that, by the way. It's also cheap labor. All right? A lot of typesetting, though, is sent overseas now. Again, reason being cheap labor. Here's the deal, though. Computers really have created a very cheap labor in computation. Whereas in the past, during Wells's time, computation was actually forked over to somebody called a computer. And they did the computation. You'd ask them, hey, find the cube root of 3. Well, that job's gone. And why is that? The digital computer basically does it incredibly cheaply, all right? Really cheaply. Let me type this in, though. I'm going to type in 3 to the 1/3. I'm sorry about that. And if I do that, I want to point, there's a point to this, it doesn't do it for me. I have to force it to do it. So I'll just say 3.0 to the 1/3. Whoops. And I get a number, right? Are we getting the same number that Wells's technique leads us to? Of course you could. I got to be honest with you, looking at what Wells was doing, they kind of petered out pretty quickly, by the way. The reason being computations were brutally difficult, but not for a digital computer to do it. They really aren't difficult for a computer to do it. All right? Thank you.